This is the Earth Science Classroom. Welcome back to the channel. This video is on energy production and we're looking at coal. In particular, what happens when coal is burnt. So the composition and the different rank and grade of coal and how this affects when the coal is burned, and looking at the different effects to the environment, both terrestrial and atmospheric, when we burn coal. This is the Earth Science Classroom. Welcome back to the channel. Before we discuss the combustion of coal, we must first describe what coal is. Now, coal is compressed and pressurized dead organic material and matter, mostly vegetation and plant material flora, which derived from ancient coal forests dating back to 320 million years ago to around 180 million years ago, during the time of Pangaea, where the majority of these epicontinental and terrestrial coal forests were in tropical swampy conditions, creating vast amounts of organic matter which is going to die and decay and go through the coalification process to increase the percent of carbon within this material and squeeze out through basically diagenesis, which includes the increasing burial sequence with the addition of pressure and temperature applied to the material, creating this sedimentary rock made from biological organic remains. Now, the composition of the average bituminous coal with an average carbon percent per weight of around 84%. And in addition to carbon, we have oxygen with 6% weight, sulfur less than 2% weight, nitrogen less than 2% weight, and hydrogen around 5%. So the majority of this coal is going to be 84% carbon by weight. And then we have a very small amount, less than 1%, of trace elements such as magnesium, silicon, aluminum or aluminium, calcium, and iron. And then we add in some rare earth metals. And of course, we have to add in the inorganic minerals such as the pyrite, the clays, and the quartz, which together is collectively termed ash. So the combustion of this sedimentary rock is directly linked to its chemical composition, i.e. carbon, oxygen, sulfur, nitrogen, and hydrogen, and also its formation and the origin and how this dead and decaying plant material became coal over the course of hundreds of millions of years of burial and physical and chemical changes. In today's industrial society, we utilize coal in coal power plants to produce electricity through combustion and capturing the heat generated from this exothermic and redox reaction when coal is ignited and combustion occurs. Now, combustion is defined as the chemical reactions, including physical changes in mass transfer and the release of heat, which means exothermic, and the chemical reactions are mainly redox, which means the transfer and movement of electrons. So reduction is the addition of electrons in a chemical reaction, and oxidation is the loss or removal of electrons in a chemical reaction, and the oxidant, in this case, which produces or creates oxidation in this reaction, is oxygen. So a lot of O's right there. The coal in the coal power plants is first pulverized into a fine powder, which would increase the surface area and allow for ignition and combustion to occur in a more efficient manner. After the heat has been applied to the coal, the initial chemical reactions releases the volatiles or the gases within the coal, as mentioned prior, referring to the carbon and the additional elements within the coal itself. Now, when coal is ignited containing these elements, the chemical reactions include reduction and oxidation through oxygen in the atmosphere will quickly react with the released volatiles from the coal into the atmosphere, and then creating various emissions. And then finally, the last stage of combustion is the ignition of the remaining solid material, or the char, which is left over from when the volatiles are released or escaped during combustion, and the char, or the solid carbon material. And in addition to the char, or the solid carbon, you also have the production of particulate matter and soot through the combustion of inorganic ash residue, or the minerals that are in the coal to begin with. And the final temperature of the coal fire can range based on the coal type. Generally, coal fires range between 2,000 degrees Celsius, which is about 3,500 degrees Fahrenheit. The purpose of igniting and having coal combustion within a coal power plant is to produce electricity for general use. This is done through the capture of heat within the power plant. The heat is going to turn the water into steam. The steam then turns a turbine, and in turn, this is going to move a generator and create electricity. However, the focus of this video is not entirely on the combustion of coal, but the emissions released from coal combustion. So far, we've discussed the coal's formation and origin in terms of coal forests, and also its chemical composition, and looking at the burning of coal, the ignition of coal, and the combustion of coal through the power plants, and the various reactions chemically and physically that go on during combustion. And now we're going to focus on the result of combustion, the effects of burning coal in the atmosphere and in the environment in general. So these are the various chemical compounds that are produced when the volatiles from the coal and the coal itself with the carbon are ignited and combustion occurs, and the chemical products form in the atmosphere, such as CO2 or carbon dioxide, SO2 or sulfur dioxide, NO2 or NOx, which is nitrous oxides or nitrogen oxides, and soot, which is mostly particulate matter of 2.5 micrometers, and carbon monoxide or CO. And in general, the CO2, SO2, and NO2 or NOx, they are all forms of greenhouse gases, which are in general gases and compounds that react in the atmosphere that change the composition chemically of the atmosphere, which can lead to an alteration in the absorption of radiation within the atmosphere, mostly the troposphere and stratosphere. Firstly, the CO2 is formed from solid carbon plus O2 equals CO2, a gas, and also if there's incomplete combustion present at the time of combustion within that immediate environment, which means a lack of oxidation where you have the transfer of electrons and the lack of oxygen, which is the oxidant, to form CO2, you get the product CO or carbon monoxide. This can also be a result of excess air, too much oxygen, and this can also form soot, which is the fine, small, black particles, usually particulate matter, 2.5 micrometers, from this incomplete combustion process. Then we have the formation of SO2 in the atmosphere, which is the reaction between sulfur and oxygen, O2, which equals SO2. Then we have the NO2 or the NOx, which is formed from nitrogen plus O2 equals NO2, and the NOx is multiple oxides, which comes from the formation of NO plus NO2. In addition to the different gaseous compounds, you also have the heavy metals, which are trace elements and impurities in the coal after combustion are released. These include mercury, arsenic, lead, nickel, and selenium. And in high concentrations, these can be toxic for the environment. And we also have unburned coal and can produce soot and a term called fly ash, which is a mixture of silica, iron, and is a main component of the coal combustion residues, or CCR. There are many effects in the environment caused by the chemical compounds produced after coal combustion. The CO2 is responsible for changing the radiative forcing of the atmosphere and the air molecules within the troposphere and the stratosphere, which is going to alter the way that the air molecules absorb and trap and reflect heat or energy. The SO2 is associated with photochemical smog and acid rain formation. The NOx or NO2 is related to tropospheric ozone or ground level ozone, and with VOCs being added can form smog and also acid rain. And this can have a knock-on effect with the water cycle and surface bodies of water. With the increased nitrogen can cause eutrophication. Then we have the soot and the carbon monoxide, which can form both smog and tropospheric ozone and can increase the amount of particulate matter, 2.5, in the atmosphere, which would cause a decrease in the air quality and also environmental degradation. As an overview, coal is burned to produce heat and electricity for both the developing and developed world. However, there are severe drawbacks with burning coal, as discussed in this video. Now, climate data suggests that over 15 billion tons of CO2 is produced by burning coal every year. Now, CO2 is one of the byproducts that coal combustion produces, as discussed in the video. In addition to CO2, you have NO, NO2, NOx, SO2, particulate matter 2.5, ash, and char. Now, all of these byproducts are hazardous to the environment in large concentrations, and together they make up the majority of greenhouse gases, except for one gas in particular, which is water vapor, H2O. The various environmental effects or hazards associated with coal combustion or burning coal are the production of tropospheric ozone or smog, acid rain, and the decrease in air quality. And all of these will affect both humans and our ecosystem. This is the Earth Science Classroom. Thank you for watching the video. I really appreciate it. And if you get a chance to like and subscribe, that stuff really helps the channel. Thank you so much. And see you again in a future video.